Series, the method of differences. This is quite an algebraic intensive little section. Okay, so we can use the method of differences, which basically involves if we have a sequence that can be written in the form one term minus another. So when we're summing the series, we're able to think of one term minus another term to find each term. What you will find is that when we write this out, the first term is equal to one term minus another, second one term minus the next, third term is equal to this term minus the next, and so on. Okay, it all gets a little bit complicated here. However, when we actually write this out, it becomes quite obvious, because what you'll start to notice is that a lot of these terms just cancel. So, as far as cancelling, you'll notice minus F2 will cancel with the second. Minus F3 cancels with F3. And this pattern will replicate all the way down. So you end up with the final term giving us F1 minus Fn plus 1. And again, with most sequences and series, it is best if you can write out a few of the terms and start to spot the pattern. If you're not quite sure, write a few more terms out until it is obvious. Moving on to example 1. This method can be best seen through the use of examples. However, quite often we have to start with some algebraic manipulation. We're given the identity that 4r cubed is equal to the right hand side, and we want to show that they are equivalent. In this case, I'm going to start with the right hand side. So multiplying this all out. And at this point, it is best to be careful and take your time. So, r squared plus 2r plus 1. From this, we're subtracting r squared times r squared minus 2r plus 1. Expanding those out gives us r4 plus 2 r cubed plus r squared minus r to the 4 positive 2r cubed minus r squared. At this point, hopefully you can see r to the 4 minus r to the 4 cancel. Positive r squared minus r squared cancel, leaving us with 4r cubed, which is what we were looking for. So as required. Now for part B. Part B says hence prove, so the hence implying we're going to use the result from part A. So hence prove by the method of differences that the following summation is equal to a quarter n squared brackets n plus 1 squared. Okay, so let's start by thinking what we have. Well, I can see an r cubed and an r cubed. So let's start by looking at the right hand side and thinking, okay, what happens if we sum that? Well, then we know it's equal to 4r cubed. So the summation of, so remember we're looking at the method of differences here, and we're going to go from the first term to the nth term. So let's write some of this out. So for the first term, so r equals 1, we have 1 squared, 1 plus 1 all squared, minus 1 minus 1 squared, 1 squared. Now we could simplify that to give us, so 1 plus 1, 2, squared 4, so 4, and the second one goes to 0. When r is equal to 2, we have 2 squared, so 2 plus 1 squared, minus, in brackets 2 minus 1 squared, 2 squared, which gives us 36 minus 4. Moving on to the third term, we can see that this is going to be 3 squared, 3 plus 1 squared, minus, in brackets, 3 minus 1 squared, 3 squared, which gives us 144 minus 36. You may now start to spot the pattern. So as we move further down, we can now think, what if we go to the nth term? Therefore we're left with n squared, n plus 1 squared minus n minus 1 squared, n squared, which is equal to the same thing. So at this point we're trying to spot what cancels, and as we can see, the 4 and the minus 4 cancel. So that's equivalent to those two cancelling. Next, we can see the 36 and the minus 36, which is equivalent to the next two. And you start to spot that there's a pattern. So that would cancel with the next one. The 144 would cancel with the next one. And that would continue all the way down, noting that sort of diagonal cancelling, which then means at the final stage, the n minus 1 squared, n squared, will also cancel. So when we can think of this now as a series, so remember a series is we're taking the summation of them. Well, this summation, let's cancel that, is equivalent to, looking at what we have here, we have our minus 0 plus n squared, n plus 1 squared. So therefore we can see that the summation of r squared, r plus 1 squared minus r minus 1 squared, r squared, between r equals 1 and n is equal to n squared brackets n plus 1 squared. However, from before, we can hopefully recognise, this is going back up to our question, that this is equivalent to 4r cubed. So actually, this is equivalent to 4r cubed between r equals 1 and n, which is then the same as 4 times the summation of, from the first term to the nth term of r cubed. Dividing both sides by 4 then gives us that the sum of the r cubed terms from the first term to the nth term is equal to a quarter of n squared, n plus 1 squared, and we have our result that we were looking for. Example 2. Here we want to verify that these left-hand side and right-hand side are equivalent, and then hence, so using that result, to find this summation using the method of differences. So let's verify first of all. So I'm going to look at the right-hand side first of all. So this is equivalent to r plus 1 over, so I'm going to use a common denominator of r times r plus 1, which can then be combined into one fraction, which can then clearly be seen because our r's cancel, leaving us with 1 over r brackets r plus 1 as required. Next, or hence, we want to use that result. So the sum of 1 over r times r plus 1 could be rewritten as the sum of 1 over r minus 1 over r plus 1, and that's the sum between the first term and the nth term. So I'm going to write this out. So r equals 1, that gives me 1 over 1 minus, well, 1 plus 1 is 2, when r equals 2. Therefore we have 1 over 2, subtract 1 over 3. When r equals 3, we have 1 over 3 minus 1 over 4. And if we keep going with this, to finish with r is equal to n, we end up with 1 over n minus 1 over n plus 1. Now remember, the sum is the summation of the series. So if we want to add all these terms together, however, hopefully you can spot that a half and minus a half cancel, a third and minus a third cancel, meaning that as we were to follow this down, you would start to spot that diagonals are cancelling, meaning that that 1 over n is going to cancel. And we can see now that we're left with 1 over 1 minus 1 over n plus 1, which simplifies to 1 minus 1 over n plus 1. So we now know that the summation from the first term to the nth term of 1 over r brackets r plus 1 is equal to 1 minus 1 over n plus 1. Finally, tidying this up, well, that's the same as n plus 1 over n plus 1 minus 1 over n plus 1, which simplifies to n over n plus 1. And we have our summation. Example 3. Here we want to find the following summation. However, we want to do that using the method of differences. So the first thing to spot is here, this is one term, and to use the method of differences, we need it into two terms where one is being subtracted from the other. Well, this looks like it could be split up using partial fractions. So let's first of all try that. Looking at the denominator, I see that it is a difference of two squares, which I then know is equivalent to a over 2r plus 1. So next step, let's try and solve this partial fraction. So I know that 1 is equal to a 2r minus 1. So I've multiplied through by the common denominator to get that. Now let's try r is equal to a half. Therefore 1 is equal to, well, 2 times a half is 1, take 1 out of 0. And for the b, so therefore that gives us that b is equal to a half. Next, let r equals minus a half. So therefore 1 is equal to, well, 2 times minus a half is minus 1. Minus another 1 is minus 2. And for the b term, well, 2 times minus a half is 1. Plus 1 is 0, so b is not there. So therefore, we can see that a is equal to minus a half. Which now means that 1 over 4r squared minus 1 is equivalent to minus 1 over 2r plus 1 plus 1 over 2 times 2r minus 1. So now we want to find the summation. So the summation of 1 over 4r squared minus 1 between r equals 1 and n can be seen as equivalent to this partial fractions between 1 and n. And you could, of course, write those the other way around if you preferred. Okay, let's try looking at this series. So when r is equal to 1. Well, when r is equal to 1, we have multiplying through minus 1 over, so 2 times 1 is 2, 3, 6, plus r is equal to 1, so 2 times 1 is 2, take away 1, 1, so 2. When r is equal to 2, so filling this in, we have, so 2 times 2, 4, 5, 10. And the second one, 2 times 2, 4, 3, so 6. And you start to spot, hopefully, that there's some cancelling going to happen. We'll do one more just to double check. Well, filling in 3, 2 times 3 is 6, plus 1 is 7, times 2, 14. On the next one, 2 times 3 is 6, take away 1, 5, times 2 is 10. And this could continue on down until r is equal to n, which gives us minus 1 over 2, 2n plus 1, plus 1 over 2, 2n minus 1. Now let's see about the cancelling. So we can see here, minus 1 over 6, positive 1 over 6. Minus 1 over 10, positive 1 over 10. Minus 1 over 14, and the next one will cancel. And as you can see, that diagonal cancelling means that the bottom right will cancel. So diagonal cancelling, meaning that last one will cancel. So to get the summation of this series, do it in black, if we add all of those, you can see that we're going to have a half minus, and we have what our summation is equal to. So the sum of 1 over 4r squared minus 1 between n and r equals 1 is equivalent to this. So the next step is really just, can we tidy this up a little bit? So as far as tidying it up goes, well, this is going to be 2m plus 1 over 2 minus, which now simplifies down to 2n over 2 brackets 2n plus 1. And the final step, we can see that both terms are even, so this leaves us with n over 2n plus 1, which is our answer. So that is the sum of, from the first term to the nth term, of 1 over 4r squared minus 1.